Have you ever wondered how Arduino programming works? Well, you're in the right place. Arduino programming is a fascinating world where electronics meet coding. It's a realm where you can bring your ideas to life, be it a simple LED blinker or a complex home automation system. You see, Arduino is an open-source electronics platform that's made programming interactive hardware accessible for everyone. It's not just for the tech-savvy or the engineers, it's for the curious minds, the problem solvers, the creators and dreamers. Learning Arduino programming opens a world of possibilities. It's a skill that's beneficial in a multitude of fields, from robotics to design, from education to the Internet of Things. And the best part, it's fun and fulfilling. In this video, we will guide you through the steps of Arduino programming, breaking down the complex into comprehensible bits. Ready to dive into the world of Arduino programming? Let's get started. Before we start programming, we first need to understand the Arduino hardware. Think of Arduino as a mini computer. It's a microcontroller board that acts as the brain of our projects. It's here where we'll upload our programs. The board houses a microcontroller chip, which is essentially a compact but powerful computer that is able to execute the instructions we write in our programs. Now let's talk about digital pins. These are like the hands and feet of our Arduino board. Digital pins can read and write digital signals, meaning they interpret information as either on or off, 1 or 0, true or false. We have 14 digital pins on an Arduino Uno board, each labeled from 0 to 13. These pins are instrumental when we want to interact with LEDs, buttons, and other digital devices. Moving on, we have analog pins. Unlike digital pins that understand only on and off states, analog pins can comprehend a range of values. On an Arduino Uno, we have 6 of these, labeled from A0 to A5. They come in handy when dealing with components like temperature sensors or potentiometers, which provide a range of output values. Last but not least, let's talk about the power supply. Arduino can be powered in 2 ways. The first is through the USB port, and the second is via the external power jack using an adapter. The board can handle voltages between 7 to 12 volts. It's important to note that different components connected to the Arduino board might require different voltages. So always make sure to check the voltage requirements of your components. In summary, the Arduino hardware is a versatile tool featuring a microcontroller board at its heart, surrounded by digital and analog pins that interact with the outside world and powered by a flexible power supply system. Understanding these components and their functions is crucial as we embark on our journey into Arduino programming. Now that we are familiar with the Arduino hardware, we can start setting up the programming environment. The first step in Arduino programming is setting up the Integrated Development Environment, or IDE. To kick things off, you'll need to download the Arduino IDE. It's available for free from the official Arduino website. Once you're on the site, navigate to the software section and choose the version that's appropriate for your operating system. After you've selected the right version, the download will begin. While it's downloading, let's discuss what the Arduino IDE is. In essence, it's a software platform that allows you to write and upload code to your Arduino board. It's designed to be as user-friendly as possible, making it a great tool for beginners and seasoned coders alike. Once the download is complete, you'll need to install the software. Open the downloaded file and follow the on-screen instructions. The process is straightforward and should only take a few minutes. Now that you have the Arduino IDE installed, let's take a look at its main features. The interface is divided into several areas. At the top, you'll find the toolbar. This is where you can access various commands such as verify, which checks your code for errors, and upload, which sends your code to the Arduino board. Below the toolbar is the text editor. This is where you'll write your code. The IDE supports syntax highlighting, making it easier to read and understand your code. Next, there's the message area. This is where the IDE displays feedback about your code. If there are errors in your code, they'll be highlighted here. Lastly, there's the text console. This is where you can see detailed output from your Arduino board. It's particularly useful for debugging your code. And there you have it. That's a brief overview of the Arduino IDE and its main features. With the IDE set up, we are now ready to write our first Arduino program. Writing a program may sound daunting, but with Arduino, it's quite simple. let's dive right into the process of crafting your first Arduino program. The beauty of Arduino programming lies in its simplicity and its structure. At its core, an Arduino program, also known as a sketch, consists of two main functions: setup and loop. The setup function, as the name suggests, is used to set up the conditions for your program. It's the opening act where you define your variables, initiate pin modes, start using libraries, and more. The setup function is executed only once, when you first power up the board or hit the reset button. Picture this as setting the stage for a theatrical performance. The stagehands roll out the props, adjust the lighting, and set the scene. Just like that, the setup function prepares the Arduino for the tasks at hand. Next, we have the loop function. This is the heart of your Arduino program, where the main logic resides. The loop function is executed over and over again, in a continuous cycle, as long as the Arduino is powered. Imagine the loop function as the actors on the stage. They perform their roles, repeating their lines and actions, as long as the show goes on. Similarly, the loop function houses the instructions that your Arduino repeats, creating a rhythm of actions. Let's take a simple example. Suppose you want to blink an LED connected to your Arduino. In the setup function, you'd define the LED pin as an output. Then, in the loop function, you'd write instructions to turn the LED on and off at regular intervals. And voila, you have your blinking LED. Writing an Arduino program is just like telling a story. You set the scene with the setup function and then let the characters play out their roles in the loop function. So don't be intimidated by the term programming. It's just a way of communicating with your Arduino, a way of telling it what to do. And with a little practice, you'll be fluent in no time. Congratulations, you have just written your first Arduino program. Now that we have our program, it's time to upload it to the Arduino. So what's the process? Well, it's delightfully uncomplicated. With your Arduino connected to your computer via the USB cable, we'll be using the Arduino Integrated Development Environment, or IDE, that we set up earlier. First, we need to ensure that the correct board and port are selected. You can do this by going to the Tools menu. Under Board, select the Arduino Uno if it's not already selected. Next, under the Port option, make sure the correct port for your Arduino is chosen. If you're unsure which port to choose, simply unplug your Arduino, see which port disappears, then plug it back in and select the port that reappears. Now, we're ready to upload. Click the arrow button in the upper left corner of the IDE. This is the Upload button, and it will compile your code and upload it to your Arduino. You'll see a progress bar at the bottom of the IDE showing that the code is compiling. Once it's done, the IDE will attempt to upload the code to your Arduino. But what if something goes wrong? Well, the Arduino IDE is quite helpful in this regard. If there are any errors in your code, the IDE will highlight these in the code window. You can then go back, correct these errors, and then attempt the upload again. Sometimes the error might be due to a problem with the connection. Check your USB cable and the port to ensure they are working properly. If you're still encountering problems, don't despair. There's a vast community of Arduino users out there who have likely faced the same issues and found solutions. A quick online search can often provide the help you need. Now, if all has gone well, you've successfully uploaded your program to the Arduino. The onboard LED should start to blink according to the pattern you've coded. With the program uploaded, your Arduino is now functioning with your custom program. And just like that, you've taken a significant step into the exciting world of Arduino programming. Enjoy the journey.